Lightspeed for having me today. I greatly appreciate that, and thank you all for joining today. This talk is a half talk, half workshop, and it was originally designed to be about 90 minutes. So obviously we're not going to be doing 90 minutes today. Yeah, real quickly, as Maggie indicated, I'm a big Kanban fan. And I believe that Kanban in many ways you can use Kanban whether you're using Scrum or not, but a great way to visualize your work and really learn how to manage the work that you have. Because lots of times we get a lot of work that comes in and we don't have the tools necessarily to manage that work. So I spent a lot of time thinking about things like system optimization, how we deliver value, what does the flow of work look like? And I've got a couple different talks around that topic. And one of the things that I feel that there's some really good uh, charts and tools and metrics that you can use. And one of those is the CFD, which we're talking about today. Oh, by the way, that is my license plate on the far right there, limit whip, which is one of the practices of Kanban. So if you ever see that license plate while you're driving in Virginia, that is me. So I'll go ahead and say hello. So today's agenda, part one, and why do we care about the CFD? Yeah, so we'll talk briefly just about why should we care about something like this? What's in it for you? And then we'll talk about how to construct the CFD, and we really get down to the very nitty gritty, just so that we're all on the same page of what exactly this thing is doing. And then we'll talk briefly about three important flow metrics and how they're actually embedded in there, which is kind of neat. And then part two is what I've already talked about, kind of the workshop, and where I'll be presenting some CFD patterns, and we'll just practice observing what we see and kind of walking through and thinking about, if we came across a team with this pattern, what might we do? And it's good to kind of train our brain to how to respond to something like this when we see these types of charts and patterns. And if I do have time, for those who love burn down charts, I'm going to challenge you to think a little differently about how a CFD might be more beneficial than simply burning down. So that if we have time, I'd love to talk about that too. All right, so why would we care about the CFD? What's in it for you, right? Well, no surprise, it's a graphical view of the flow of your work. All right, you're going to have presumably some way of identifying the work that you have. And as these items or these work items come into your board, there's a flow of some kind. So the CFD tracks what that flow looks like. And we're going to look in detail on how it does that. Some of the benefits there, it'll help identify recurring patterns. You can look at this graph and begin to see certain things happening. And you can ask yourself, is that a fluke? Is that something that I need to be paying attention to? Perhaps they're bottlenecks. You can even begin to think, well, if that is a bottleneck, what was the impact? Are we noticing something now because of what we've observed? Um, it also helps us keep front and center the relationship or the interrelationship between three very important flow metrics. I'm not going to tell you what they are right now, but there are three important flow metrics that kind of embed themselves within the CFD. And I subscribe to the belief that it provides deeper insight than a velocity-based burn up or burn down chart. So to make sure we're all on the same page, on the bottom right is a cumulative flow diagram. And I put this slide up here because this is going to serve kind of like as a template for the rest of the day today. I have on top, on the far right, is a Kanban Scrum board. It's one that I made up. I'm not saying your board has to look like this. But everything to the left of that double line is options or a backlog, if you want to think about it that way. And everything to the right is the workflow that this team has identified for themselves. And it's discover, implement, verify, and done. Pretty straightforward, 3 steps and then done. If you want to think of discover as the work that goes into analyzing, well, what exactly is this work before you implement it or before you develop it, before then that you test it or verify it, that's fine. I chose those words purposefully. I won't get into that now, but discover, implement, verify is the flow of work for this particular fictitious team. And those little stickies there, those little yellow squares, are the work items. Whether they're user stories or their defects or features, or that doesn't matter so much. What does matter, and should go without saying, but I'll say it, is something that delivers value, right? We don't want to necessarily be tracking something that doesn't. So nonetheless, but that's kind of what's set up. The CFD below mimics what you're seeing above. So that discover, implement, verify, done are the bands of the CFD. And I have a little key there, discover, implement, verify, done. And each color coordinated band represents that that item on that board that you see above, okay? So I'll get into a little more detail as we go on, but I'll wrap this part up by saying the x-axis is time, and the y-axis, the vertical axis, is the number of items in the workflow. And I'll talk about what that exactly means. And again, if you have any questions, please let me know. All right, so we're going to start by constructing the CFD. I'm going to spend just a few minutes really breaking it down to the very basic, just so that we have an understanding of what's going on. We have the same setup as before, but I've also included down below a table. And this table simply captures the discover, implement, verify steps, or the flow that you see on the left. So in this particular example, on this date called October 1st, when we look at our board, we see that that moment in time, we have 2 items, work items in discover, 2 items in implement, 2 items in verify, and nothing has been done yet. And I have that down below in the table. And here in October 1st, you can also see, if you use the color key, that there are 2 items in verify. If you count it up, 1, 2, that'd be 2. 2 items in implement, the difference between here and here. So you would count that horizontal difference between those 2 horizontal lines, if you will. And then discover is this part up here. From here to here, there's 2 items. And so that's October 1st. And if we look, we come into work the next day and things have moved. People have done stuff, right? Well, there's been some shifting. What has happened? Well, the first thing you might notice is 2 items have finished. So total done is 2. So there's your total done down there. And a couple other things. We now have 2 in verify. We did before. We don't know if they're the same 2 items or not, which is an interesting component of all of this. But we do have 3 items in implement. We have 3 items in discover. And that's exactly what this is showing here. 2 are done, 2 are in verify, 3, a little bit wider band, 3 in implement, and 3 in discover. And we take a look at October 3rd, same thing. Now we notice 2 more items are done. And there's one thing I want to point out specifically about this, because people sometimes get a little tripped up here. This bottom band down here, this total done, is always done, And it's a cumulative count of done. All right. It's not how many finished since yesterday. It's the total amount complete. So as you can see down here in my chart, it says total done, and there's a 4. So there's 4 items from here to here. Even though 2 items completed from here to here, we are measuring or keeping track of the total amount done down here. And again, the rest of the bands, same way we have talked about it already. Now, this is great way to think of a CFD. What I like about this is it's very explicit about the snapshot frequency that you're taking your measurements. In this particular case, 1 on October 1st, 1 on October 2nd, 1 on October 3rd. Maybe it's every day at noon or right after the stand-up or something like that. What this doesn't necessarily show is the flow component. And one way to get a better idea of that is, well, with the CFD, we really are connecting those snapshots in time by drawing, a line between the particular dates. All right, so you can see here, I've drawn this line that's starting to connect those dates. just starting to connect those bar charts, right, of each one. But really, a CFD does a little bit more than this. Really, what a CFD does is it doesn't stop here. It says, well, let's color that all in so it looks like this. And it's this view that begins to help us understand a little bit better what, as we build this out here, what's going on in terms of the snapshots are still there, but it allows us to have a better mental picture of really what's happening. What's the flow look like here in this cumulative flow diagram? One thing to keep in mind, though, is to always question, always be curious about what is the snapshot, because it could be the case that maybe even though the dates down below say October 1, October 2, October 3, it could be the case that I'm taking a snapshot twice a day. And it's just that I'm not labeling it that as such. So one thing you want to be aware of when you look at that x-axis is maybe go back to the team if you're brought in as a consultant or somebody, like how often are you taking these snapshots? Just something to think about as you're doing this. All right, so as our Kanban board on the left is changing, you can see the team is working, more things are moving to done. We're building out our CFD. I got the table down below that's just mimicking that. And there you go. There's a CFD. Okay. All right, well, let's move on to talk about a little bit more about what's going on behind the scenes. There are three important flow metrics. I've hinted at this several times. Does anyone want to take a guess what these three are?
Question on the CFD diagram that you're showing on the last slide. Is this Kanban or Scrum? Just out of curiosity.
Yeah, it actually doesn't matter. It's neither. It's both. What's important here is we've identified a flow. This could be very well a Scrum team, and we're just keeping track of the number of items that are flowing through each step of our workflow. This could be a Kanban team. I mean, technically, it could be a oh, God forbid, waterfall team, but we're just keeping track of items through a workflow. So it could be any of the above.
Okay, thanks.
You're welcome. Anything else? Anyone else?
I think that this tool helps a lot on keeping the teams motivated, isn't it? Because as you are all the time looking, yeah, it is, but it is not continuous. But you can see, oh, we are making achievements. We are getting the things done, because if you don't have this visuality, it could impact on the engagement and the motivation of the teams.
Yeah, I really like that comment, and I think your comment's gonna play into this, the second part of today, because when you are able to visualize
Sorry.
what's going on, it could motivate you because you could be seeing things that you don't like and you want to change, or seeing things that you really like, well, let's keep doing that. So yeah, I completely agree with you that it is a way to really motivate the team and be very transparent about it too. I mean, after all, this is a representation of their flow. It's a reality. That's the way it is.
Yes, it is what it is.
Yeah. Okay, so the three important metrics are work in progress, cycle time, and I'm defining cycle time in this instance as well, I think I'll actually talk about it in just a second. So, and throughput. So throughput is a ratio, the number of items completed per unit of time. Let's take a look at these. Oh, real quickly. These three metrics, I put this slide in here to let you know that I know that these three metrics have a relationship. And the relationship that you see is here, and it's called Little's Law. It's way beyond the scope of today's discussion. Little's Law is also bound by 5 very important assumptions that are also beyond today's discussion. Nonetheless, they're very important that these assumptions hold true in order to get the true meaning out of the interrelationships of these metrics. Nonetheless, that doesn't mean that we cannot use a CFD. We cannot glean information from the CFD itself. But I just throw this in there because people will stop me and say, did you know that's Little's Law? Yes, I do. But we're not going to necessarily get into that right now. All right, let's take a look at a CFD. And I want you to note that even though my x-axis shows a October 1st, October 8th, a 1 week increment, we're actually recording data every single day. Okay. So let's take a look at that first metric, WIP. How do we identify WIP in a CFD? Well, it's pretty straightforward. I even showed you a little bit earlier. That's really that vertical distance on your chart. You can do a vertical distance for a particular band. You can do a vertical distance for the entire system, and that's what I'm showing here. Everything that's in your system, discover, implement, verify, that is your WIP. Any vertical place is your WIP, and the way you actually show it is by those red lines that I've provided there. Is the difference if you take a line and you were going to all the way over for both the top and bottom, you can see that at that particular moment we have 9 items in the system. So October 29th, we can say there are 9 items. You can look back and say how many items were in our system on October 29th. We know the answer is 9. Okay, so that's the first metric. All right, so I've dimmed that a little bit, and let's take a look at approximate average cycle time. Well, the cycle time is the horizontal distance from the moment from the point that you're starting, here is October 29th, to when you go all the way to done. And I want to be clear that I know cycle time and lead time have 1,000 different definitions depending on who you read and where you read and what you read and all that kind of stuff. I'm defining, for this purpose of the next hour, I'm defining cycle time as the clock starts the moment you bring a work item into your first doing column. In this case, it's discover, all the way to it gets to the moment it leaves verify and goes into done. That is how I'm defining cycle time. And that should be pretty obvious the way I've even drawn this graph, right? It's come in right here on discover all the way to done. That is, if we look back in time and we say, for items that were brought in October 29th, or let me rephrase that a little bit. For an item that is in WIP in the discover band on October 29th, on average, how long did it take before it was done? And that's your answer. That is your cycle time. And in this case, if you draw your vertical lines down there, you can see that it's about 21 days, about 3 weeks from the moment, you have to be very careful how you say it, from the moment in which on October 29th we had an item in discover, how long on average would it take approximately to get to done? Takes 21 days. So that's your approximate average cycle time. All right, so I dimmed that. Let's take a look at the last metric. For those who like geometry, this will be very satisfying for you because we will complete the triangle and you have your average throughput. Okay, so this is the rise over run. This is the rate, the number of items done, in our case, per week. Okay, so we know that we have 21 days, and we also know that we have 9 items. Well, as you can see in the bottom left over here, basically what we're saying for a throughput is we had 9 items over 21 days. That's a throughput of 9 over 21, or 3 over 7, or about 3 items per week. The slope of that done line is showing us that this particular team is completing about 3 items every week. And whether that's good or bad, we don't know yet, at least, but we know that that is what the case is. Okay. One other important thing to note, if we had more time, we could get into this, but this is the triangle that we've just looked at. Okay. In fact, it's right here. Okay. So I've taken everything else away. There, just pay attention to the WIP. You can see the WIP. Let's just say, for the sake of argument, that we've modified for whatever we changed. Let's pretend that the discover band was actually wider, and it would look like, it would look like something like this. I made the discover band wider. Everything else is pretty much the same. Look at the impact that has on cycle time. The fact that we have more items in the system is now pushing out our approximate average cycle time to, sometime between November 26th and December 3rd. And this probably shouldn't be too much of a surprise because we hear all the time, the more items you have in the system, the longer it takes any one particular item to finish. That's why we're always saying, stop starting, start finishing, right? This is a neat graphical way of just seeing that. Assumptions that I talked about are in play also, but something to think about. So, when we're talking about let's bring in more items into our flow because one of these things is bound to be done. We're actually making things worse for ourselves, and this has been proven. I mean, it is a law. It's been proven that is the case. More items you have, assumptions given, the on average, the longer things take. So it's just something to think about when you are working with the team. Really focus on those items that you currently have in play and get them to done before you reach back to the backlog and say, well, let's just bring something else in. Let's spend a little bit of time looking at some patterns. And this is what I want us to do. I'm going to be presenting some patterns, and there are 3 things that I want you to be thinking about, and I'll facilitate us through this together. But the first one is pretty straightforward, but yet I think is really powerful. And that is simply, what do you see? What are you observing when you look at the CFD? Pretend you're walking into a team room, for the first time. You're just hired. They hired you to help this team. You walk in and, let's say this is the greatest team ever. They've got a nice big CFD on the side of the wall, and but they have no idea what it means. Your job is to help them. So what are you noticing? You're looking at this thing. They're like, we created it. We don't know why we're creating it. Somebody told us to. But what patterns are you seeing? What are you observing? Is there anything that looks out of the ordinary? Basically, what are you observing? That's number one. The second thing is, and this is where you start to play on your experience, is why might what you're seeing be occurring? What could be causing this pattern? Have you ever seen this before? What has, everything I'm writing here, what has prior experience taught you? What questions, based on what you're seeing, what questions might you want to ask back to the team? Okay. And then always, what does the team think? It never hurts to put things back to the team. What do you think is happening here? Okay. So what do you see? Why do you think it might be occurring? And then lastly, what might you suggest? This is why they hired you, right? What are some things that you might suggest to the team? Maybe you've done them before. Maybe there are ideas that you've seen other teams use. Have you seen a pattern before? And this is what I've done. So let's try this. And again, what has the team already tried? And did it work? Okay. So 3 questions. I'll have them on the far left of the slide. And let's take a look at the pattern. I'll give you a couple minutes for each one. I'll give you a minute just to look. Let's take a look at the first one. Here's the first one. I'll be quiet, I promise. But what do you see? Why do you think? And by the way, the what do you see? It's not meant to be a trick question or anything. It's just, what are you observing? Why might it be occurring? And what might you suggest? I'll give you a minute. Just look at it, think of those things, and then I'll facilitate a discussion. Okay. So I would love to hear from someone. What are you observing when you look at this CFD? What's sticking out to you, if anything?
The discover column is growing.
And validation.
Excellent. Yes.
And the
Discover-
done line also, the bottommost band, slow and relatively flat progression, right? The
Yeah.
done line.
Yep. Yep. Very good points. Anything else?
The discover option is growing very rapidly,
Yeah.
though,
Yeah.
but the bands are very narrow, though. A very little growth, I guess so.
Yeah. Not much. So the comments that we heard, discover is growing. That's probably the biggest thing that we're noticing here. The done line, the throughput, kind of steady for the most part. It flattens out a little bit right here, but it's and these bands are. There's nothing in my mind. There's nothing too crazy going on here. But let's talk about this in particular. We notice that the first step in our, once the clock has started, now we're measuring things. Discover column, it's growing, it's getting bigger. Why might something like that be occurring?
That's good news and bad news at the same time.
Okay.
Because it seems like there is a bigger demand, but the capacity of the team is not able to respond to the demand. So I will ask, what about the capacity? I will ask why the done items is getting stacked. What is happening with the team? What is happening with the planification? I will ask a lot of things about the target, the goal that they want to achieve, and also about how is the team. Maybe it is stressed with a lot of discovery items, but seeing that, oh, we have done a lot, but it is getting stacked.
Yeah, yeah. I mean, these are good points and good questions that you'd want to ask back to the team, right? Are you stressed? Why are you bringing more in? Because when we look at everything else, the fact that they're bringing more in is really having little impact on implement, verify, and done. So, I mean, that's why it's growing, right? I mean, it's getting bigger and bigger. But why is that the case? Any other thoughts on why this might be happening? We may not know. We probably don't know. So we're trying to be smart about this when we go to the team or to management. Any other
Mark,
thoughts though?
is it because there's a bottleneck in implement?
It could be. Maybe there's something happening in implement that it's preventing us from. I mean, it's worth asking, sure. Maybe
And
there's
maybe
not enough people in
changing,
implement,
and maybe there are changing requirements, scope creep, maybe.
possibly. So how would scope, changing, I see what you mean. Scope creep, they're just adding more, so they're putting more in. Yeah, that's a really good point.
Yeah.
Does the team has what it need when it comes to discovery? Because discovery eventually is like, an open, box. And
Yeah.
we all go within assumptions, but are those assumptions still valid? So maybe a point we can ask this that, hey, can we do a quick check as we go?
Yeah, I love that. So maybe the team doesn't have what it needs. So like, well, let's bring something else in until we get what we need fixed or
Maybe.
finalized or whatever. All right, we're going to move on to number 2. This is different, completely different, has nothing to do with the prior one. A new pattern that you see in front of you, a little bit different. Take a 30 seconds, 40 seconds to look at this one, and we'll just kind of go through the same exercise.
A sort of waterfall where development stops and validation is happening.
It's but it'd be an interesting question to ask. Is this a waterfall team? And why are you asking that?
Yeah, because if we see, right, from the at certain point between November 19th or that time frame, or maybe that is a holiday where, I don't know, that can be questions because that's fall during the Thanksgiving time frame. But the thing what I see is like, implementation is completely full stop. And
Yeah.
then we see verification happening over there at the same pattern we see between October 29 till November. So what's going on? There is no QA work being done. Why things are not moving into done when development was happening? So some questions
Yeah.
over there.
Yeah, excellent points. We've got some, it's certainly worth asking questions about what's going on here. What's going on here? We notice that there's no verifying done. It could be that the work items don't need verification. Maybe they don't.
Yeah. And it looks very effective, a strong whip progress, right? A strong double whip is there, and it looks very much stable, provided that there is no verification, obviously,
Mm-hmm.
Is it possible? One thing I want to throw out here is it possible that stuff is moving through the phases more quickly, and that's why we're getting like data that looks like this? If we were recording twice a day, we might see something like there's more stuff in the verify column on October 29th and it's just not recorded because by the time the day ends, we've already moved the verify stuff to done. Is that
It's
possible?
very possible. And that's an excellent point. And which is why it's so important to kind of establish what those snapshot snapshot frequencies are. But yeah, you're absolutely right. It's possible. It's worth asking about. Yep. I like that.
And it is a very good throughput, right? It is very nice and no bottlenecks.
Yeah, that is a really good point. We're not noticing in this particular made-up example, we're not noticing that our throughput is being affected. In fact, we're noticing things or well, once they hit here, they're they continue to get things done at a consistent rate.
Yes.
So it may not be a problem
Yeah.
that you're observing here.
Yeah, but I was wondering because yeah, maybe it is not a problem thinking about the throughput, but maybe it is a problem thinking about the cost of this throughput. Maybe, I don't know.
Yeah.
Because they seem to be very like how do you say this word? They seem that they learn something during the 3 first weeks, or something happened after the 3 weeks. They began to be more effective, and it's very good. But at the end of the day, it is okay. What is this costing to the enterprise, for example, to have this throughput? Because maybe I don't need so much people here to do this work, or maybe I could be in a good position to take more achievements, to make more, to take more goals, to take more challenge, to go for them, because as the team learn to be more effective, so we can get more results in other things, or we could reorganize the team. I don't know. I am just speculating.
Yes. Yeah, these are all really good points. So thank you very much. Let's see, we're not going to be able to obviously go through all 7 examples. Let's take a look. Let's see, I got so many fun ones. Let's take a look at this one. One of the first things to look at is the x-axis here. What do you notice about the x-axis? And what might you draw? What conclusion might you draw, or at least what question might you want to ask about the x-axis?
If this team's working in a 2-week sprint.
Yeah, that's excellent. I agree. Starts on a Wednesday, ends on the following 2 weeks, Tuesday later. Some interesting things. I'll kind of walk you through this since we're butting up against some time. One thing that I would look at is, and it depends when the snapshot is being taken, going back to the gentleman's point made a little bit earlier. But it looks like the sprint starts with items already in play. We have 2 items in implement. We have 1 item in implement, 1 item in verify. That'd be something to ask about, especially when we look over here, we notice that not everything was completed at the end of the sprint. Okay. So we know we have 10 items, but only 7 items are done. So could this be a team that is not finishing the items that they bring in during a sprint? Now, this is just one CFD for one particular sprint, but one thing to look at perhaps is other CFDs. Are you noticing a pattern where, hey, we bring in 10 items, but we're only getting 7 done? Is that recurring, or is this an anomaly of some kind?
Mark, a quick question. You were mentioning as to when this snapshot is taken. Can you kindly elaborate on it, how it impacts the flow diagram with respect to when it was taken, if you don't mind?
No, I don't mind at all. Let's take a look at this one. It's maybe a little bit better to understand.
Yeah.
All that I'm saying is that just because your x-axis is labeled a particular way, and here I've labeled it every week, that doesn't mean that the snapshot is taken every week.
Okay, got it.
Yeah. In fact, I put a note here, data is recorded every day. So this is pretty, but it's possible things can move even, at any, even if I do it at noon every day, this CFD may look a little bit different if I were to take a snapshot if I had it twice a day. You know what I mean? So,
Yeah.
but that's what I mean when I say that.
Oh, got it. Thank you.
Oh, you're more than welcome. This one, I've seen, if you ever do a CFD for a Scrum team, they kind of look like this to some degree. This happens to be a Scrum team, at least I was pretending it was, for a 3-week sprint from here to here. But at the beginning of the sprint, nothing's open, and then everything's kind of in play. And then at the end of the sprint, this is a good team. They close, they finish everything. Then the next sprint, everything opens, and then they close it. So this stair step approach, if you've ever done a CFD for Scrum teams, they tend to follow a pattern like this to some in some manner. Real quickly, what I wanted to show here was an example of a CFD where something goes down. A CFD should never have a band that goes down. If you have a CFD where a band goes down, then there's something wrong with the data that you're collecting. That includes the done as well. Things can be steady, they should never go down. Lots of times you'll see this with people who will take an item out of a column and put it backwards into something else. And then makes the something else, the one preceding, bigger. That's what you would see here. And then the one that you took it away from, smaller. And hence you would have a dip. Real quick, when I was working at an organization before where I am now, we were told that we had to use a to-do doing done board for the Scrum teams. And the reason why I bring this up is because a lot of Scrum masters would create burndown charts, and they would look something like this. All right, they have a to-do doing done board, everything is done, and this is what a burndown chart would look like. And you'd look at it and you'd say, oh, you did some things. The first things were completed on, that second Wednesday. Excuse me. Most things were completed on, I was wrong. Most things are completed on that Monday before the end of the sprint, and then everything else is completed on the Tuesday. So what I'm saying is, you notice some things completing here and here. And that's what the burndown chart does. A CFD, even for a to-do doing done, very basic. I'm not a big fan of to-do doing done, but even for this is what a CFD could look like. This part right here is just this. It's just inverted, just flipped upside down. So your throughput, which is really what this is, your throughput is right here. But with the CFD, even a to-do doing done, you get just a little bit more information. What is that information? Well, we can see that at the beginning of the sprint, they opened with 8 items, or at least 8 items were already in play. But they opened with 8 items. That's a little bit more information. 2 items were not done yet. You don't have that information up here. You just know that they completed things, but you don't know how many were opened. Here, you at least have that. It's not much more to go on, but it's a little bit more. When you do, here's another Scrum team with a little bit more elaborate discover, implement, verify, done. But this is what the burndown chart would look like. Now, what would you rather have, this or this? If you're doing just a burndown chart, this is what you get. And again, this line is just the inverse of this. But with the CFD, look at all the other information that you're getting. That's it. I went through this really quickly, but hopefully that gave a little more insight on the power of the cumulative flow diagram and what you can do with it and just how it's created behind the scenes and what it's trying to do. So with that, I want to thank everyone for joining me today, and I hope you have a great day.